Okay, let's look at example 4. So a relation is defined by this. I gave you a piecewise function. F of x equals 1 minus x if x is less than or equal to -1, and it's equal to x squared if x is greater than, or excuse me, just greater than -1. So we need to evaluate and sketch this graph. So f of -2. You have to look at your domain piece to know which one to plug it into. So you have to ask yourself, okay, is -2 less than or equal to -1, or is -2 greater than -1? It is less than -1, so you plug it into the first rule, and you get 3. F of -1, so is it less than or equal, or is it greater than? And it falls into the less than or equal to category again. So 1 minus -1, and you get a 2. If I ask for f of 0, 0 is greater than -1, so I plug it into the second one, so 0 squared is 0. Alright, to sketch this graph we need a t-chart. Our rule in Algebra 2, college algebra, pre-calculus algebra, any of those, was always to make a t-chart for each piece. So if I'm looking at the first one, you have to start at this breaking point. So I start at -1, and then I need things less than that. So if I put in a -1, 1 minus -1 is 2. 1 minus -2 is 3. 1 minus -3 is 4. So we have -1, 2. Because of the equal to up here, this -1, 2 is a closed circle. -2, 3 would be a closed circle. All the rest of them are closed. -3, 4. So what's happening is this was my first point, and it's extending like that. When we do these piecewise, they only extend one direction. The second piece. Even though this isn't equal to -1, I do have to start by plugging in a -1. What will happen is my circle is just going to be open. And then I need things greater than that, so like a 0 and a 1. So -1 squared is 1, 0 squared is 0, 1 squared is 1. So -1, 1 is open, 0,
Please
0.
excuse this.
Okay, if you plug in a 1, you've got this point here. If you can't tell what's going on, you could put in another one. If we put in 2, you get out 4. We have this parabola here. So we have a portion of a parabola extending like that. As always, if you guys have questions, since we are in class right now, feel free to pause this and raise your hand. Happy to go over anything with you. The last thing we need to look at in this section is domains. If we are talking about domains of a function, so a domain is possible x values. When we look at those, there are really 3 things we need to consider. If there is a fraction, your denominator, cannot equal 0. If you have an even radical, so that's like a square root, 4th root, 6th root, so on. The radicand, that's the thing underneath the radical, has to be greater than or equal to 0. That's only for the even radicals. Odds can be anything. Okay, the last one we didn't use as much, but it is still something that came up at the end of college algebra. If you have a logarithm, the argument, the thing you're taking the log of, has to be greater than 0. So in looking at the domain, those are the 3 pieces we have to consider. Okay, so let's do some domain problems. Find the domain of each of these. So A, we have an even radical, a square root, so that means the thing underneath has to be greater than or equal to 0. So if we subtract that, r is greater than or equal to -2. I do want interval notation, so it would be bracket -2, comma, infinity. B. We have a fraction. We know that in a fraction, the denominator cannot equal 0. So if I pull out an x, we have this. So we know that x can't be 0 or 1. In the past, if it's more than one value x can't equal, you can just list them. Same is true here. If you did choose to write interval, it would be -infinity to 0, union 0 to 1, union 1 to infinity. C. There is no radical here. There is no fraction. There is no logarithm. So there are no rules being broken. So your domain is just automatically -infinity to +infinity. D. We have to consider each of these. So for the 3 over x, you have a fraction, so we know the denominator can't be 0. So x can't be 0. The second piece, we have a radical, but this is an odd root. Even roots have to be greater than or equal to 0. Odds, there is no rule. So this could be anything. So I don't even have to worry about that. My domain only has one thing it can't be, so we would put -infinity to 0, union 0 to infinity. E. It's supposed to be a fraction. So in a fraction, the denominator can't be 0. So we can do box method here. Multiply to 12 and add to 7, that would be a 4 and a 3. So x can't be a -4 or a -3. Again, you can leave it that way because it's more than one value. If you want the interval, -infinity to -4, union -4 to -3, union -3 to infinity. And finally, f. We have a log. If it's a log, the argument, this 2x plus 5, has to be greater than 0. So subtract your 5, divide by 2. X is greater than -5/2. So since there's no equal to, we do a parenthesis, that'd be -5/2, comma, infinity. So that is the end of this section. You have the rest of time to work on that handout, which is due tomorrow.